dokie. So if I know that y equals 6x minus 11, then I can replace this y with what it equals. And the reason I like that, so I'm just going to rewrite this second equation, but instead of writing y, I'm going to write 6x minus 11, because y equals 6x minus 11. And the reason I like this is because this is one equation with one unknown, what we learned. So we're just kind of building on what we've learned. It's because I can solve this, no problem. So I'm just going to go ahead and distribute and collect some like terms and subtract 33 from both sides and divide by negative 20. So hey, I got one. So x should be 2. And so, well, that's great, but what was y? Well, y equals 6x minus 11. So just plug this back into that. 6 times 2 minus 11. So 12 minus 11 is 1. So the y is 1 and the x is 2. And that should be the one point that makes both of those equations true. So I just put it into that one. Let's put it into the other one to make sure it works. So if I do negative 2 times 2 minus 3 times 1 equals negative 7, does that really work? Negative 4 minus 3 equals negative 7. Negative 7 equals negative 7. Pretty darn impressive, right? So I do encourage you to check your answers, because sometimes we do these so often we forget what we're doing. We're finding an x and a y that satisfy both of those equations. It's pretty impressive. Let's do it again. So this one, the y equals x minus 1. So I'm going to replace the y in the other guy with x minus 1. So I'm just going to rewrite this top one, 2x minus 3. And instead of writing y, I'm going to write what it equals. Y is x minus 1. And now I have this equation, which I've known how to solve for a while. This is just one unknown. I'm okay. So distribute that negative 3. So it'll be 2x minus 3x plus 3. Make sure you distribute that negative. Equals negative 1. So negative x plus 3 is negative 1. So negative x is negative 4. So x is 4. Got one. So now plug that one in to either one of those equations. This one's quite nice though because it's solved for y. So y equals 4 minus 1, so y equals 3. And so we've got the point 4, 3, and that's our answer. So you can definitely tell it works in this one. The 3 will equal 4 minus 1. Let's check to make sure if it works in this one. When the x is 4, the y is 3. So I've got 2, the x was 4, minus 3 times the y was 3 equals negative 1. So does 8 minus 9 equal negative 1? Yes, it does. Awesome. Let's do it one more time. So the y equals this guy here. So I'm going to substitute the y in this with what it equals. So it's 5x minus 4, and instead of writing y, I'm going to replace the y with what that equals. I'm going to substitute that in. So now we have an equation with just one unknown, the x, and I'll have 5x plus 12x plus, minus 20 equals negative 3. 17x minus 20 equals negative 3. 17x equals 17, so x is 1. So x is 1, plug it back in. The y should be negative 3 times 1 plus 5, so it looks like the y is 2. So 1, 2 should work. We'll check it in this one. When x is 1, we'd have 5 times 1 minus 4. The y was 2. Does that really equal negative 3? That's 5 minus 8. Does that equal negative 3? Heck yeah, it does. Awesome. The ones I want to get to, these are quite nice, the ones we've done, because we've always had like a y equals, y equals, y equals. But when you get down here, it's like, oh man, they didn't tell me y equals this, so it's harder to substitute. But that's okay. I could just solve that for y. If I just kick the 4x over, y equals 4x plus 6, then I'm back to what I had before. I can, now that I know exactly what y is, I can replace the y in there with what it equals. So I'll have negative 5x minus the y, which is 4x plus 6, just substituting that in, equals 21. So I have negative 5x minus 4x minus 6 equals 21. So negative 9x minus 6 equals 21. So negative 9x equals 27. So x equals negative 3. And then plug that back into either one of these or that one, doesn't matter. Every single equation, if you hadn't made a mistake, every single thing you've written is true. So you can plug it back into any one. But I'm thinking this one where you have the y equals already is the easiest. So the y will equal 4 times negative 3 plus 6. So negative 12 plus 6, so y is negative 6. So my ordered pair would be negative 3, negative 6, and I leave it to you to check it. In this next one, everything we've done so far has been y equals, but there's no reason why we can't do x equals. This one here, the x is far easier to isolate than the y. So the x will equal 2y plus 11, and then I'll just substitute the x with what it equals. So take your pick, whichever is the easiest to isolate, do that. So solve for one of them, solve for x or y, and then substitute it into the other one. That's our gist. So I have negative 7, the x equals 2y plus 11, so I substitute that in, and then minus 2y equals minus 13. Just keep going now. Now we're home free. So negative 14y, negative 16y minus 77 equals negative 13. So negative 16y equals 64, so y is negative 4. And then to get the x, you've already got this lovely equation set up that says that x should be 2 times the y value plus 11. So 2 times the negative 4 plus 11. So negative 8 plus 11, so x equals 3. So y, so the x is 3, and the y is negative 4, and those are the x and y that make both of those true. I leave it to you to test them. Okay, that's it for now.